Welcome guys to the last edition of our Python series. In this particular video, we are going to be looking at object-oriented programming in Python. Let's start by creating our main.py. Now, what is an object? Most programming languages, they operate based on objects. But what is object in the real sense? So object can be anything substantial, anything with values. Take for example, we can have orange. Orange as a fruit is an object. Your laptop is an object. You, yourself, is an object. Your TV is an object. Your car is an object. So anything that can be quantified, that has value, is an object, including the air is object. And objects have properties or characteristics. What these objects are known for, what they do, what they can do, what they cannot do, what properties do they possess, what characteristics do they possess, these are what we call objects. Now, an object cannot stand alone. There is another concept of the use of class. So let's take, for example, we want to create an object. We basically, in most programming languages, we use class. And we can call this class my class. And we can do something like this. In this case, this is a class. So what is a class? A class is the blueprint of an object. Let's go to W3 School so that we can understand clearly what an object stands for and what a class stands for. Now here on the W3 School, object. Python is an object-oriented programming language allowing you to structure your code using classes and objects for better organization and reusability. Advantages of object-oriented programming. Object-oriented programming provides a clear structure to programs. It makes the code readable and understandable. It gives it a very clear structure. Object-oriented programming also makes code easier to maintain, to reuse, and to debug. So when you want to reuse an object, it is easier to inherit an already established object and use it as a parent object to all other child objects. We are coming to that. I will explain it later on in detail. It helps to keep your code dry. So dry means do not repeat yourself. So you don't rewrite a code that you have written before so many times just to achieve so many results. You can write one object or one class and reuse it anytime you want to use it. It also allows you to build reusable applications with less code. So you write less code and you achieve more result. That is the concept of object-oriented programming. Let's understand what a class is. A class defines what an object should look like. Like I said before, a class is the blueprint of an object. We use it to set up a structure that our object is going to look like. Okay, take for example, we can set up a structure for fruits, and these fruits, for every fruit, the fruit must have name. This fruit must have test. The fruits must have color. Then the number of fruit, that's the quantity. Okay, so these are some of the things that we can specify in a class. And now when we come to the fruit, which is the fruit is a class, we can pick apple as a fruit. Apple is now an object. This apple can have a name, apple. It can have a color, green, red, yellow. It can have quantity. Now, these are inherited from this class, which serves as the structure of our object. So that is the concept of class and object. So the class defines what the object should look like. An object is created based on that class. Let's go on to a little bit of practical. Let's create a class. Let's call this class animals. Now, this can have a name. Let's say that this is a dog. So this is our class. If, for instance, we want to access the name of this class, let's see what happens. So we can do animals dot name. Let us use, Ctrl-J to open our terminal, and we're going to use PowerShell. Now let's run Python main.py, and we have dog. So here is the class of the animals, and then here is the name of this animal. But we can do more on this. But for now, let us try and understand how to access properties of an object before we go on to inheritance. This dog can have some features, some of the characteristics, like the height. And the height may be 23 cm. We may not put the unit. The dog has a sound that it makes, and this sound that the dog makes is barking, and is a function. So we can still have a function inside this object. So let's have sound, and this sound is a function of bark. But I'm going to make it a little bit easier for us to understand. So the function can be print back, a string back. Now, how do we access all the properties of this animal? We can say print, and this time around we can print the function back. But here you will notice we can't go direct into this, but I'm still coming to show you how these things can work. But this is to show you that we can still have a function inside our object class. Now, if I want to call the height, it's going to be animals dot the height. Now, this is going to be the general property of all animals. We can create other animals like creating a dog, and we make it inherit some of these properties right here. So in essence, let me clear this off. In essence, the dog has a name. Sorry, the animal has a name, has a height. So these are classes that all animals must inherit. Now let's create an object. Now let's create an object called dog. And the dog will now inherit this class, animal. So now that the dog has inherited this class, which has name and has height, we can do the same thing as saying that if we print it out, this is going to be dog dot the name. And let's see. You can see it gives us dog. So this is the class which is serving as the blueprint to our object, which is serving as what our object will look like, what our object is going to have. Whereas this is the object inheriting this class, and then which once it inherits this class, it automatically possesses all these attributes that is embedded inside this class. So this is our class and this is our object. And this is how object and class are related. And this is how we also create them. But in real life, we don't just leave object like this. So let's do more. Now, in real life, we don't use this kind of object. It is not basically useful. So let's do something more useful. Let's say we have a class of person. Yes, let's say we have a class of person, and we usually use the underscore init underscore function to collect or initialize these objects, and then you pass in this self into it, and then collect all the arguments that is going to serve as the properties of this object or the properties that this object is going to have, and then you pass it inside. Take for instance, I have name, I have age. I can also have height. Okay, and to initialize the height, I will say self dot height. I think the spelling here is wrong. So I have HEIGHT. Okay, and this is going to be height. All right, so now if I want to call the person, so let's say this person or first person or person one, I can say P1 is person, which is this class, and then I need to pass in all my arguments. So let's say the height of this person is 1.7 meters. In that case, if I should print p1 dot name. In that case, if you run this code, it gives in John. You can see there. If we want to get the age, which is this or this, and you can see we have received the age argument here. So in that case, if we change this to p dot age and run this code, we get 36. And the same thing with the height. So without this particular function, we cannot be able to initialize this particular object. Let's do one more example. Okay, so let's do one more example. Let's start with the animal again. Let's create class animals or animal. And here we create a function def underscore underscore init underscore underscore, because it's a function. And then we pass in a parameter self, and here we can take the name of the animals, we can take the color of the animal, we can take the quantity of the animals, and we can take the age of the animal. We can also take the owner of the animal. So in this case, we are passing in all the parameters, all the properties that we want each object that we create to have. And here we need to initialize each of them. So we are going to say self dot name is going to be name. Again, self dot color is going to be color. Again, self dot quantity is going to be quantity. Again, self dot age is going to be the age of the animal. And finally, self dot owner is going to be the owner of the animal. So we have passed in all our arguments inside this function. Right now, we can create other animals. Sorry, this is supposed to be like this. Right now, we can pass in other animals. So, for example, let's create a dog. So, dog is now an object, and this object is going to receive all these properties that exist within this class. Because this thing, the class here, carries all the blueprint, all the things that we need all the animals in this application to have. So here we are going to just inherit the class and say animal this way. And then we now pass in the positional arguments to each of these parameters. I know you know we did positional arguments in our previous class when we did functions. So if you have not seen that video, you kindly should go and see the video, because the video will serve as a basis for you to understand what we are doing here. Positional arguments is that these are our parameters, or the parameter we need to work. That's the variables we need to work. And they have positions, which means name comes first before the color, and then before quantity, before age. So if you should pass any value here, it follows this pattern as well, meaning that they take position. So this is 1, 2, 3, 4, and so on. So it takes positions. So which means the first argument I'm going to receive here is supposed to be the name of the animal. So in that case, is the dog. The next argument I should receive is the color of this dog. Let's say it's a black dog. And the next argument I'm going to receive is the quantity. So let's say we have only one dog. The age of this dog, let's say 2. The owner of this dog, let's say Anthony. So we have taken all these arguments. So right now, if we do print and say, let's use F format, and we say the owner of the, here we can pass in dog dot name. So the owner of whichever whichever object you have is going to take its position here. Of the dog name is Mr. or Mrs. Let's take dog dot owner. Let's see what happens. So you can see the owner of the dog is Mr. and Mrs. Anthony. If we change, or if we create another, instead of, so now let me show you how this class functions. We can actually create another object and call it goat, and then give it values like goat here. So you no longer need to go and set up something like this, because you already have the blueprint. And in this case, if we should also print exactly the same thing right down here, watch. You can see the owner of the dog is Mr. This, and you can also see the owner of the dog. Okay, so here, this is going to be goat name instead, and no longer dog name. You can now see automatically we have owner of the goat is Mr. Anthony. So we no longer need to, when you want to run the same code over and over again, you start rewriting it anytime. The blueprint serves as what you will use to create each of the objects. So we can have goat as an object, and the goat has the name, the color, the age, the quantity, the owner. We can have a dog with the name, the color, the quantity, the owner, the age. We can have a cattle or cow. We can have a chicken. So once you create them, because they are animals, they will automatically inherit from this class. And that is what objects enables us to do. And you can see, instead of writing this again and again and again, we only inherit them like this. And then we pass in our values, which are going to be the arguments that we received in this function here. And that's how it works. Now let's look deeply into objects. Let us let's use just something very simple. Let's just do dog dot name. Let's clear this and run this code again. You can see we have dog. All right, now let's look at more detail. What if we don't want to, or we don't know what actually to return of this object? We don't know the properties the class has. In that case, if you went ahead and then print the dog, look at what you will have. So you have underscore main dot animal object at this. So it doesn't make sense. Now, there is a function called string representation or underscore str. So we can create this function def underscore str underscore, and here we can pass in the self, and whatever thing that we return here is gonna be the string representation of the object. So let's do this like this and say self dot name by self dot owner. So in this case, we want to print the name of the animal and by the name of the owner. All right, so let's try this out. You can now see we have dog by Anthony. And if we should change this from dog, or rather, we should have goat. And it inherits that class of animals. And the name is goat. And the color is green. Let's wrap it in string. And the age is 3 years. And the height is 1.02. And the owner is Samuel. In that case, if we should say print the object goat, let's see. You can now see we have goat by Samuel. So this is what the stringify does. So the underscore str is a string method that returns the string value of that object. So take note that these are the objects while this is the class. So you can create other objects using this same class and they will inherit all the properties of this object or object of this object class. Okay, it's very simple, right? Again, let me tell you that it is not a must or compulsory or mandatory that you must use self as this parameter here, but whatever thing that you use here should be what you would use in other places. So if I come here and I want to use OB, then it means that here and every other places where I have self is supposed to be OB. So, but in general, we use self. just to refer to the particular class. So we are telling it is this class, the self of that class. That's just it. So, but you can use anything you like. You can also modify object values. For example, before we print this dog, we can actually do dog dot name is now let's say parrot, and let's run this code again. You can now see parrot by Anthony, even though dog was received as an argument, but here we have reassigned it a value. So all the methods that worked on the functions and on the list, set, tuple, string methods, all those methods can still work here. For example, we can still delete this particular object goat by just using del and then goat. Very simple. If we run this code, we will have an error which says name goat is not defined. Do you mean float? And this is because with the del, it deletes it and you're trying to print it. So it's not going to work. It's not going to show you anything. So it's going to throw an error telling you that there is nothing there. So that's just that's it. So you can do a lot of things. Can use dot update, dot capitalize, that dot anything at all. So let's try the dot capitalize. Let's actually do the name dot capitalize. So if you just do it in your IDE and tell me what you have. When you want to create an object, so let me just do this. When you want to create a class or anything in Python and you don't actually know what to pass in, just use pass. With this, it's going to override the error that may come out of this code. If you run this, there is no error. So the pass is used just to override the default error that would have occurred if you leave this place empty. That's what we use the pass to do. Okay? Let us look at inheritance in object-oriented programming in Python. So let's do something very real. In an application, we have users, and these users are classified into the admin and the students. So let's have admin and have students. So we should start with creating the parent class, and this class is going to be the person or the user class. So this user class, let's create a function to initialize it, underscore underscore init underscore underscore, and we have self, and then we can take the name and the gender of this person, and then this is going to be self dot name is going to be name, while self dot gender is going to be gender. We can also have the string representation, but for now I'm not going to do that. Now, this is the user. So we can now have another class inheriting this particular user. So we can have another class called the student, and this is gonna inherit the user. Okay. Now let's just pass. Let's try accessing student dot the name. But before we can do this, we need to receive the following arguments, right? We need to receive these following arguments. So how do we go about this? So instead of printing student.name, we can actually create a variable. Let's call it x or student1. Student1, and say that this student1 is student with the following arguments. So let's have the name of the student, which is gonna be let's say Samuel Ajayi, and then the gender is male. Now let's do print student1 dot name. Now let's watch and see what will happen. You can see we have Samuel Ajayi. So in that case, we have created a class for the users, and we also created other classes that we inherit from this class. So they are inheriting the name and the gender from this class, and that's why we passed it inside of this student. So we have two categories of users, which are students and, let's create another one, teachers. And this teacher will also inherit user because they are the users. Let's just pass. In that case, if I do the same thing and say teacher one is teacher, and then we can now take the name of the teacher. Let's say Donald Smith, and then take the gender as male. If we go ahead and print teacher one dot the name, we will see we are going to print Donald Smith. So this actually entails that we have two child classes which are inheriting from this particular class. Now let me show you how the string representation can also work. If we do a function __str __ and passing self and then return, please, this function is supposed to be here, the return will be here, and then we return f and say self dot name is self dot gender. In this case, we no longer need to start calling the name, so we can just say student1 and print student teacher 1. Let's see what will happen. You can now see we have Samuel Ajayi is male, Donald Smith is male. And this is because we are inheriting from here. We can actually pass in their status from here. Let's remove the pass and say status, or rather let's initialize this particular class with def. So when you want to initialize, just use underscore underscore init underscore underscore, and let's pass in self, and then this only takes status. And then here we can now say self dot status is status. And right here we can do the same thing for the teacher. We remove the pass and then we use status. Now if we call this and also pass the status of these teachers, we will receive those status. If we pass the status inside here, we will also receive the status, because here the classes are independent. Okay, they are here. These are different classes which can actually pull out that this person's status is that they are students, while this person's status is that they are teachers. Okay, so in that case, that is what object inheritance is, because right here these classes are inheriting from this particular class. That's inheritance. Thank you. Let's go to the next. And finally, the last thing I would want to talk about or speak about is the polymorphism. So polymorphism stands for many forms. You can use some classes in many ways, and that is what we call polymorphism, the ability to use a single class in so many different ways. That is polymorphism. So polymorphism allows us to use our code in different ways. The ways may not be related, but we can reuse these codes to do so many things that differs in some little ways, but we use it in so many ways of doing one thing. Okay, that can be polymorphism. Now let's look at example of polymorphism. Let me paste this and then we explain. So we have a class vehicle, and this vehicle has these following attributes: model and brand, and which we have initialized here. And then for the movements made by these vehicles, so we have that the vehicle should print move. So this is a method. A function which lives inside an object is called a method. That's the easiest way I can explain it to you. When you have any function inside an object, that function is a method. So we have this method, which is the movement made by each vehicle. But we know that cars move because we have specified it here. So this is going to be inherited by this class since you are passing in the vehicle inside the car. So automatically it's going to take a brand, model, and then the movement is going to be move. But we all know that the boats do not move, but they sail. And in that case, we created a class for the boat and inherited this vehicle, but then we defined another um, method with the same name of move, and we reassigned it as a cell. And then we did the same on the plane, and we reassigned the move method as fly. And here we are calling on the car objects, and then we assign them as Ford, and the and the model is Mustang. Then the boat is Ibiza and the model is Touring 20. The plane is Boeing and the model is 747. Okay, so now we are using an iterator, the for loop, to loop through these objects like the car object, the boat object, the plane object, and then we want to print their brand, we want to print their model, and we also want to print their move. Okay, because their moves are method which has print already inside it. We no longer need to print it, we just call the object or the method x.move. Now if we run this code, look at what we have. We have that we have Ford, Mustang, Move, Ibiza, Touring, Sail, Boeing, 747, Fly. So you can now see we are able to use this same move method in different ways without causing any glitch. That is what polymorphism is. I will do more video on polymorphism. If you want me to do more video on polymorphism, please leave a comment in the comment section, and please don't forget to subscribe and share this video to your friends. Comment out if you have any question so far, or there is a specific thing you want me to look into in object-oriented programming. This is not all about object-oriented programming. We have not even done made a scratch to all about object-oriented programming. If you want me to go deeper than this, please leave your comment on the comment section, and I am going to do my next video if I have more comments that I should do more video on the object-oriented programming. For now, let's call it a day. Take care, and I'll see you in my next video. In my next video, I'll be doing Django. We are going to be moving into Django for our full stack web development. Thank you, and God bless you.